Hello everyone, this is Arshita H. pursuing my education in Sri Venkateswara College of Engineering, Bangalore, class 4th semester, section Bhaskara. Wearing my USN with 1VE 21CS057, course title Microcontroller and Embedded System, course code 21CS43. Here in this video, we are going to discuss about pointer aliasing in a microcontroller and embedded system. Before moving on to that, we have to know about what is a microcontroller. A microcontroller is a self-contained computer system on a small single integrated circuit. It consists of microprocessor core along with memory, input-output ports, various peripherals such as timers, counters, analog to digital converters, digital to analog converters. Microcontrollers are designed to perform specific tasks and commonly used in embedded systems. Next, we have to discuss about what is an embedded system. An embedded system is a combination of hardware and software designed for a specific applications or purpose within a larger system. It is typically built around a microcontroller or microprocessor and is dedicated to performing a particular function. Embedded systems are found in a wide range of devices and applications, such as consumer electronics, example smartphones, digital cameras, automotive systems, example engine controllers, units, anti-lock braking systems, and etc. We have to discuss about types of microprocessor and types of microcontroller. First, moving on to that, types of microprocessor: complex instruction set microprocessor, application specific integrated circuit, ready to instruction set microprocessor, digital signal microprocessor, DSPs. Types of microcontroller: 16-bit microcontroller, 32-bit microcontroller, embedded microcontroller, external memory microcontroller. Where are microcontrollers are used? Microcontrollers are used in a plethora of different environments. A simple application where a microcontroller could be used in control of operation of LED light. A microcontroller can be performed to perform specific tasks and events. The microcontroller could be track the time when the button is pressed or how many times it is pressed. The microcontrollers adds intelligence into otherwise simple application, making a specific performing a more complex task. Now, moving on to block diagram of embedded system. It consists of microcontroller, microprocessor, RAM and ROM, where RAM is known as random access memory, ROM is known as read-only memory. It consists of bus, address, data and control. Microprocessor are connected to input ports, RAM and ROM are connected to output ports. Input and output ports are connected to external circuits, whereas external circuits are connected to physical devices. In physical devices, we have input signal and output signal. Moving on to characteristics of embedded system. It has many characteristics like it performs specific tasks. Embedded system performs some specific tasks. It has low cost. The price of an embedded system is not so expensive. It has time specific. It performs a times task within a certain time frame. Low power. Embedded systems do not require such more power to operate. High stable. Embedded systems do not change mostly fixed stability. Less human intervention. Embedded systems require no human intervention. Moving on to advantages and disadvantages of an embedded system. Advantages: small size, enhanced real-time performance, easily customized for a specific application. Disadvantages of an embedded system: high development cost, time-consuming process, as it is application specific, less market available. Moving on to our main topic, pointer aliasing. Pointer aliasing: when a single memory location is accessible through different symbolic names in the program. The name pointer aliasing applies specially to accessing the memory location through, although the same effect can be achieved when accessing the memory location through reference or any other way. Pointer aliasing is breaking compiler optimization and introduce hidden loop dependencies. Now we have to consider an example. Void for double into a double into b comma int n. For int I is equals to 0, I plus plus b of I is equals to a of j. In case of pointers a and point b is distinct memory blocks. Thus this code is perfectly parallelized. Consider that someone called the function within the following arguments for a comma a plus 1 comma n minus 1. In this case, pointers a and point b alias and the loop cannot be parallelized of carried dependency. Moving on to aliasing. Aliasing refers to the situation where the same memory location can be accessed using different names. For example, if a function takes two pointers a and b which have same value, then a of 0 aliases the name b of 0. We say the pointers a and b alias each other. Below is a program to illustrate aliasing in C. Program to illustrate aliasing. Ash includes studio.h int gfg into int a into int b. B is equals to b plus 10, it returns a. Int main, given data, int data is equals to 20. Function call with aliasing. Int result is equals to gfg. And data, comma and data. It prints the data using printf is equals to percentage %d, comma result. Now moving on to avoid pointer aliasing. Do not rely on the compiler to eliminate common sub-expressions involving memory access. Instead, create new local variables to hold the expressions. This ensures the expressions is evaluated only once. Avoid tasking the address of local variables. The variables may be inefficient to access more than one. Now here we come up with conclusion. In conclusion, pointer aliasing can be a tricky concept to understand but essentially for writing safe and efficient code. We have discussed common examples of pointer aliasing such as pointers in loops and techniques such as using cost pointers or passing as function arguments. By following best practices for working with pointers, programs can improve and avoid aliasing. Thank you for watching my video. If you like my video, please like and subscribe my video. Thank you.